Everyone. In the previous video, we understood what is rate limiting and we went through the token bucket rate limiting algorithm. We understood how it works basically and what its refill mechanism, and also went through the code implementation, understood its pros and cons. And today we are going to understand what concurrency problems we could face while implementing this algorithm in a multi-threaded environment. So in the previous video, I explained using an example of a single threaded environment. And now today we are going to understand what issues we might face while we simulate this algorithm in the multi-threaded environment. So now let's understand the first scenario, which is race condition in token consumption. What does this mean? So let's say now we have multiple threads which are trying to implement this algorithm for a particular user request, which are coming to our application server. So let's say initially a token bucket is having one token, and at time t0, thread 1 comes in and reads the count of tokens the bucket is holding. So it gets one token is being held at this particular moment at time t0. At time t1, another thread comes in. It again gets the count of the tokens present in the bucket, and it also sees that it is one token the bucket is holding. Now let's say at time t2, a request comes in which is getting served by thread 1, and it decrements the number of tokens, and it allows, because we were having one token, so one request would be allowed at time t2. Now as the time at time t3, again the thread 2 which has read the previous count of the token at time t1, and it is under the impression that the bucket holds one token, but however the token has been consumed. So now it again tries to fulfill the same request, and it tries to decrement. So the token count went to negative. So this is nothing but a race condition where, uh, and due to multiple context switching, which happens when there is a multi-threaded environment where multiple threads are executing a process. This is likely a scenario which might happen if we haven't considered the updation of the count of the token, or if we haven't made this operation as atomic. So at time t3, again, this thread 2 tries to decrement the tokens count and tries to serve the request. So ideally, this request should have got blocked, but due to the race condition which is happening here, as we have not handled the concurrencies and we have not made acquired locks and all those stuffs, this condition is happening. And this is nothing but like race condition which is happening at the time of token consumption. Now let's understand one more scenario where there could be a race condition, which is the bucket creation. So if you remember, as discussed in the last video, that whenever a new request is coming from a user, we try to create the bucket for that user, initializing the maximum capacity of that bucket and the last refill time at which this bucket got created. So what happens here is, like, initially, let's say when a request came in from the user, there was no bucket. It was the first request which was coming in, and thread 1 sees that there is no bucket for this particular user. It tries to at time t0 basically, and similarly at time t1, the thread 2 comes in and tries to serve the same request for, like, these two requests are coming from the same user simultaneously, and both of the threads have picked up those requests of that same user, and hence we are running into these conditions. So again, the thread 2 comes in and checks, like, is this the first time request getting made? It sees that yes, there is no bucket for this particular user, and at time t2, the bucket has been created by thread 1. And let's say at that same time, at time 3 next timestamp, the request is made by that user for serving the request which we need to do when it comes to our application server. And it tries to decrement the token and thread 1, and now the token count in the bucket for that particular user is 9. At time t4, the thread 2, which was trying to satisfy or fulfill the request which came from this particular user, tries to create the new bucket. Now what happened here is, we are overriding basically the bucket which was already present. So let's say here there was one request served. Let's say here At a time, four requests were simultaneously hit and served. So let's say that count would be, number of tokens would be six, and this overrides it. So basically, those we have lost some of the tokens which were already served, and we would go into a scenario where we will be serving more number of requests than expected. So this is nothing but lost update race condition which is happening. Now, how can we address these issues? So let's say we are for addressing this token bucket creation issue, we can use a threadsafe map, basically the concurrent hash map which we have in Java. So this stores the information of each user bucket, and the key basically will be the user ID, and the value would be the token bucket state for that particular user. So whenever a new bucket is getting created, if the same request is coming from the user simultaneously at that same time, and let's say the another thread picked up that request, it would be blocked until this operation of creation of the bucket is completed by thread 1. And when it resumes, it tries to read again whether the bucket is present or not for that particular user, and if it finds it, it resumes its work, not by creating but satisfying the request if it's possible to, from the number of tokens which are present in that bucket. So that would be handled by a thread-safe map in Java, which is concurrent hash map. We'll see that in the implementation. And to have the token consumption race condition addressed, we can have a separate lock per user bucket. What does this mean? This makes sure that whenever a refilling is happening by a particular thread, if there is another thread which is simultaneously trying to refill it, it gets blocked off for that particular moment of time. So once a refill has happened, and like the user request should be made or not, I mean by decreasing the tokens count, and all those operation becomes atomic. So that complete block for a particular user request becomes atomic. So any thread which is coming in simultaneously at that particular moment gets blocked. Once this operation of refilling and satisfying the request for that particular user is completed, then only the other thread gets unblocked to start its processing. So that way we would be addressing the race condition for the token consumption issue. Now let's see all of this in the implementation. Okay. So for addressing the race condition in the token bucket creation, as I mentioned, we'll use concurrent hash map. So this will take care of that basically. And for making each of the user request, I mean per token, I mean each of the user request which is coming. So we want to make that atomic, so refilling and the decrement of token complete of that operation for a user. We want to make it atomic. So for this, so whenever a user request is coming in, we will make this complete block as synchronized. So refilling will be also happening, as well as the decrement of the token and satisfying the request. Both of this operation will happen at the core. So either it's happening or it's not happening at all. So this is what the meaning of atomicity means. And if any other thread which is simultaneously trying to satisfy the request for the same user, it gets blocked until the execution of the previous thread is completed. And hence, this will make sure that we are addressing that issue as well. Apart from that, all the three scenarios which I explained previously remains the same. So that is not changing. So here, as we mentioned that we are creating a multi-threaded environment. So here I'm using a thread pool. I have explained this what is how the thread pool works and all those information in one of my videos. So do check that out from the channel. And if you want, I will drop a link of that video in the description as well. You can check it out from there. So here I've created a pool of two worker threads, and here we are again simulating those scenarios, and nothing but we are trying to satisfy the 10 request of that same particular user by two threads. So this is what it is doing. And uh, then the delay of 1 second before the start of the second scenario. And then the second scenario starts off. So here we are having two threads basically. So both of the threads we are calling submitting to execute this sustained task basically to the executor. So this loops technically get executed like at line number 62, it gets executed for 4 times. And then at 64 as well, this gets executed for 4 times. So both of the threads are executing it, and hence uh, we will see that in the terminal when I run this code. Again, the delay of 5 seconds before starting the third scenario where we were checking for the ideal state. And then same way here I'm making 12 requests again and seeing whether all of those are satisfied or not. So technically only 10 requests would get satisfied and two of them would get blocked off. And both of them submitting this executors to both of them the task of executing this. And yeah, that was. So now let's understand the scenario one, which is burst of request. So the request is coming at this particular timestamp. So it is nothing but hours, minutes, and seconds. So at 56 second, we have simultaneous 10 requests coming in. So now we have two worker threads. So each one of it will pick up the task and will start processing. So simultaneously at this particular time, two requests came in. Both of them got allowed. Then the next request was picked up by thread 2 at the same time. So this is the burst of requests, right? All of the requests are coming at a go simultaneously. So both of the threads which are available at that point of time will start picking up each of the tasks and start processing it. So all of those 10 requests would be allowed. Now, let's say, uh, okay. Now let's say we have the second scenario where we will see the sustained requests after burst. Now here we will be the next request which is getting made in this scenario is at 19:58:57. So it is like 1 second after it. So technically our token bucket should have two tokens now, right? So two tokens will get refilled at the time when this request is made, and both of this request which is coming simultaneously to our collection server are getting uh, fulfilled. So both of them are getting allowed. And then simultaneously after every second the request is coming and hitting our application server. So basically here we are making sure that both of the threads are trying to access the or making the request to our application server. So in total here there are 8 requests getting made, right? So at the end, in our single threaded simulation, we were left with 4 tokens because there was only one thread which was executing and only 4 requests came in. But here, as we are having 8 requests which are getting satisfied, at the end of the scenario, we'll be left with zero number of tokens. Now let's understand this third scenario where there will be some free time at which there is no request coming to our application server. So let's say a user resumes at this timestamp, which is 9:59:07. So difference of the timestamp at which the request came in, uh, like the next time when the user resumes is like 5 seconds. So 10 tokens will get added when the request is getting made, particularly at this timestamp when the user resumes, right? So when it resumes, all of those 10 requests will get satisfied, and the 11th and the 12th request will technically get rejected at this particular time. So makes sense. So this is how the multi-threaded token bucket rate limiter looks like. And yeah, this was pretty much for this video. Hope you like the content and you are able to understand the concurrency issues which we face when we have multiple threads which are working, and when we have multi-thread environment where we are simulating this token bucket rate limiting algorithm. And hope you like the content. If you like the content, do like, share, and subscribe. And let's meet in some other video with some new interesting concepts. Till then, take care and have a nice day.